part C here, we want to find cotangent of 11 pi over 4, and we want to continue to try and use this method that kind of circumvents the unit circle. It doesn't completely circumvent it, but in some sense we won't be thinking about it much in this process. So first thing, let's find something that is coterminal with 11 pi over 4. I don't want to sketch this big of an angle. So if we did find something coterminal, let's maybe put our work right here. 11 pi over 4. Let's take one revolution off this thing. So that would be 8 pi over 4 taken away. That's going to leave us with 3 pi over 4. Okay. And this is just coterminal with this 11 pi over 4. Let's go ahead and sketch it in here. So 3 pi over 4 is in this quadrant here, the second quadrant. And you might actually know that from the unit circle, but you could, of course, figure out what portion of a rotation this is by dividing it by 2 pi. All right, so we have the angle 3 pi over 4 sketched, or if you want to think about this angle also as 11 pi over 4, that's fine. But all we really care about with this angle is what is right here. What is that angle? Okay. Well, since this is 3 pi over 4, and this is pi, well, what's in between? That must be pi over 4, right? Okay, and again, this is our reference angle. Let's go ahead and sketch our reference angle in there, pi over 4. All right, and this forms a 45, 45, 90 triangle. All right, the adjacent side should be the square root of 2. The opposite side should be the square root of 2, and the hypotenuse should be 2. And again, if we scroll up, that's just our 45, 45, 90 triangle. 2 legs are root 2, and the hypotenuse is 2. All right, let's take this a step further. So rather than computing cotangent of 11 pi over 4, we're instead going to look at cotangent of just pi over 4 and use that triangle. But before we go any further, let's think about what, not that quadrant, let's think about what the sign should be in this quadrant. Okay. So remember, cotangent is the x value over the y value from the unit circle. Okay. And this is important to remember because we're going to need to know that in order to figure out the sign. Okay. So in this quadrant, we know that x values are negative, y values are positive, right? So if we were to compute cotangent of an angle in this quadrant, x over y is going to be a negative over a positive, which is negative. Okay. So what I'm going to do here is I'm going to put this negative right here. And I'll write another little note. Cotangent is negative in quadrant 2. Right, and then next step is to use Sohcahtoa. So if we were thinking about tangent, tangent is opposite over adjacent, so we're going to want to do adjacent over opposite. Right, this is what's going to correspond with cotangent. So adjacent is the square root of 2. The opposite is also the square root of 2. So this just turns out to be -1. All right, so up next we have a couple examples where we actually don't want to use this technique. And the reason we don't want to use it Well, there's two of them. One is we won't be able to make a triangle like we've been doing here. So that's a pretty good reason not to use it. And the second reason is we can do this in a lot easier fashion for these other two that we're going to take a peek at. All right, and here they are. So the first one, it's an angle that actually lies on a quadrant. Okay, so pi over 2, we know that to be a quarter rotation. So if we were to rotate minus 5 pi over 2, okay, well then here would be 1/4 rotation in the clockwise direction. Here would be 2, 3, 4, and then 5. So we'd wind up right here on the negative x or negative y axis. Okay, so our angle looks like this. We actually, again, don't really care how we rotated to get here for this purpose, but if we did, this rotation would look like a quarter plus one whole other rotation. But the reason we don't want to use this technique we've been using on such a problem is if we do just think about our unit circle for just 1 second, maybe make a circle and I'll put it over that. All we really care about is this point of intersection between our terminal side and the unit circle. And we know that this point right here just happens at 0, minus 1. And so if we want to compute cosecant, we just need to think about, is it 1 over the x value or 1 over the y value? Okay, and so cosecant is 1 over sine, so this is 1 over the y value. So just 1 over minus 1, which is negative 1. Okay. Now, the next one, I would say you could still use this technique, but there's no point in thinking about quadrants here. If this is a pi over 6, this is just a first quadrant angle. All we actually need is the triangle. We don't need anything else. Okay. All first quadrant angles are positive. And I should reword that. If you plug any angle from the first quadrant into our 6 trig functions, you will get out a positive number because all x and y values are positive in the first quadrant. Okay. So here's pi over 6. And actually, I don't even care that this other one's pi over 3, but let's fill in the side lengths here at least. So opposite of pi over 6 is 1, the hypotenuse is 2, and the adjacent side is the square root of 3. And to compute this, I'm just going to use Sohcahtoa. So opposite over hypotenuse, 1 over 2. On to example 3. So these next few problems are going to be easier because we've tried out these parts A through E in this last example. We'll use some of those ideas. So let's start off with the fact that our angle is in quadrant 3. I'm just going to sketch that. So there's our initial side, and then I'll put in our terminal side. And this example reminded me of something that I would normally mention if we were having class on campus, but I have not mentioned it in any of these videos. So when it does come to trying to find, like, say, a reference angle, or say trying to do a problem like this one, it doesn't really matter how accurate your sketch of the angle is, as long as it's in the correct quadrant. If you put that angle in the correct quadrant and you do your math correct, you're not going to have any issues. Okay. But if theta ends up in the wrong quadrant, then we should end up getting a wrong answer. But it's okay if things aren't to scale. All right. we have our angle theta, and we said we were going to try and find the remaining 6 trig functions. Well, okay, we have one, so that makes things easy, right? We have sine theta. And if we were to maybe sketch a triangle out of this like we've been doing, we can label the sides, right? Sine of theta is equal to minus 12 over 13. Well, this is opposite over hypotenuse. So our opposite side should have length 12. Our hypotenuse should have length 13. And technically in here would be theta prime, our reference angle. Theta would start on the positive x and then end at this terminal side here. Okay. We're only looking for this angle in this little triangle at the moment. Okay. Now, if we say wanted to compute cosine theta, we're going to need to have the adjacent side, and you can see that we're actually missing that. I'll call it A for adjacent. And we can use our Pythagorean theorem to figure out what A is. So we have A squared plus 12 squared equals 13 squared. And so if you were to subtract that 12 squared on each side, we'll get A squared equals 25, which means that A is 5. And now we can go in here and we can compute the rest of these trig functions. So cosine of theta, again, is adjacent over hypotenuse, so 5 over 13. And there's one thing we need to think about here. The triangle helped us find the ratio of the side lengths, but it did not help us find the sign of this. Is this positive or negative? So in quadrant 3, we know cosine and sine are both negative. And then we could move on to tangent. Okay. Tangent, toa, opposite over adjacent. Okay, so that's 12 over 5. And then the remaining 3 are just reciprocals of all of these. So for instance, cosecant. That should be easy. Cosecant of theta is equal to the reciprocal of sine of theta, so minus 13/12. And then secant of theta should be the reciprocal of cosine theta, so minus 13/5. And lastly, cotangent of theta should be the reciprocal of tangent of theta, which is 5/12. Okay. And I realized I didn't mention much about the sign of tangent here. You can notice I left it positive, and luckily it should be. Here's why. If we're in the third quadrant, all x and y values are negative. And tangent of theta, right, if we're on the unit circle, should be the y value over the x value, which is a negative over a negative, which is going to give you a positive number. So both tangent and cotangent should be positive, while the other 4 are negative.